Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2023, 10B, Problem 15, and it deals with factorials. I hope you guys enjoy this video and let's get started. The problem states, what is the least positive integer m such that m times 2 factorial times 3 factorial times 4 factorial all the way to 16 factorial is a perfect square? So because we want all of those factorials multiplied together to be a perfect square, then I'm going to rewrite and then pair up some elements in all of these factorials. So I'm going to do m times 2 times 3 factorial because 2 factorial is just 2 times 1. So anything multiplied by 1 is still the same thing. So it's just 2 times 3 factorial times 4 times 3 factorial. Because remember, factorials is just each of the numbers. So 4 factorial would be 4 all the way multiplied all the way down to 1. So 4 times 3 times 2 times 1. So I took out the 4 and then I left it with 3 factorial. And I'm going to do the same thing with all the other ones. So it's still 5 factorial. But then when I do 6 factorial, I'm going to do 6 times 5 factorial. And then all the way up to 15 factorial times 16 times 15 factorial. And then this would give us n times 2 times 4 times 6 all the way up to 16. Okay, so that's just these numbers. 2, 4, 6, all the way up to 16. And then we still have the remaining numbers. So 3 factorial squared. And then 5 factorial squared all the way up to 15 factorial squared. And this is because we see that we have the original numbers, 3 factorial, 5 factorial, 15 factorial, but then for 4 factorial and the 6 factorial, 16 factorial, numbers like that, we had the 4, the 6, the 16, but then we had another 3 factorial, 5 factorial, and 15 factorial. So that's why it's squared. And then I'm doing this because we see that all of these are multiplication. Well, if we want all of this to be a perfect square, and then all of these right here, they are already perfect squares. That's why I wanted to pair up some elements to generate these perfect squares. Because, for example, if we have A equals B times C, right? And then if we want this to be a perfect square, and then we already know that B is a perfect square, then that means that C must be a perfect square as well. So that means that this side would be a perfect square too, so we don't have to worry about the rest. Now I'm going to write this as m times 2 to the 8 times 1 times 2 times 3 all the way to 8. And then 2 to the 8 is 256 because I just want to simplify this as far as I can. So 2 to the 8 is 256. I'm going to mod that by, so it will be mod 256. And so once I mod that, this would cancel out, and then 1 would cancel out as well, because any number mod by the same number, it would cancel out. So this would be m times 2 plus 3 plus 4 all the way up to 8. And I'm going to mod that once again to get m times 70. And so the smallest that m can be for 70 times m to be a perfect square is just 70 itself. So the answer would be C.